Or who says start? Do I? Start. Okay. Hi everybody, my name is Luis Bermudez. I work for the Open Geospatial Consortium. Originally, Raj Singh was going to give this talk. He said he was not able to do it now because he's not part of OGC, unfortunately, anymore. So this became a low priority for him. And I also broke the title, so crop it. So the original title was GeoPackage and OWS Context and Geosync. I'm not going to talk about Geosync. But I thought that in 20 minutes it was too hard to talk really good about the three of them, so I'm going to concentrate in GeoPackage and OWS Context. Okay? So how many of you are familiar with GeoPackage? So why are you here? Okay, so I will talk about then an OWS context. Oh, so now I see why you're here. Good. So how do we share geospatial data? And I have here some ideas, good ideas, maybe bad ideas, I don't know. One option is, well, let's try to do shapefiles, right? And as you are familiar with shapefiles, you need multiple files. It's been very popular since 1990. There's no topological information that you can encode. You have limit in how you use the characters, so maximum 10 characters for the field names, one geometry per layer, and so on and so forth. But it's very popular, and for simple maps, is good. Now, there are other technologies like FileGDB, also from Esri. It's a proprietary technology. Some folks have done some reverse engineer efforts. Evan Rold, is he here? No? But he's a contributor to GDAL, and he has tried to figure out how this thing works in order to have an API and provide support in GDAL. You will say, well, we can share with KML. And it's really a visualization in coding. You cannot really transport vector data with field attributes in a way that you can play with them, that you can filter, for example, by attributes and so forth. And also you have sort of limitation on the size, because you cannot put like 1 terabyte in a KML. That will be ridiculous to do. You will say, well, maybe others. You can do spreadsheets where you can, provide some information about, for example, points of interest, and then you provide the location or comma-separated values. Yeah, all those sounds like a good idea. But what we want, and this I got from a blog, internet, so I'm not saying it, was, well, can we have something that have SQLite container, right? That you can interact with like if it was a database, that we can use simple features, which is, I think, one of the most used data models for vector because it's very simple, and also that can support raster and the cold tiles. Yes. So most of you said that you knew about your package. But that's the deal about your package, and I'm going to talk into detail about what's behind your package. So your package is one file and is based on SQLite. So we use SQLite to encode your package. And SQLite is, I'm not saying it again, small, fast, and reliable. Let's see the definition that is on the website. It says, well, it's all good stuff, right? It's self-contained. You don't need multiple files. You don't need to have a server, right? You just interact via, SQL calls. No configuration, provides very good defaults, has transaction, even, like trigger transactions, is SQL 92 compatible, so you have all these good, joins and views. And is widely deployed. So if you search SQLite and who are the guys that are using SQLite, you will find that folks, Android, Mozilla, Apple, Adobe, Skype, they are all using it. So it's been proven, so let's use it. Now, there are other good things as well. So what's the maximum size? Like one of the biggest advantages is that it's 140 terabytes. Which is, I think that's awesome. It's very, very, very good. You can do the calculation there, description about pages and bytes. So that's one thing. SQL container, SQLite is very good, and that's why the spec said, let's use SQLite. Now let's talk about simple features SQL. So if you don't know about the database that OGC has, we have an implementation database. I should start before. Anybody knows what OGC is? Okay, so who doesn't know about what OGC is? Okay, good. So we have an implementation database where it is self-registration. So anybody that has an implementation of any OGC standard can go there and register, right? So here we have, this was a screenshot I took some weeks ago. So you can see, well, there are total 494 registrations for Webmap Server 1.11. That's like the #1 implementation we have in OGC. But you can see here in 4th place is the simple features SQL. We have like 92 implementations and 57 products that are compliant. And I will talk about what compliant means in a few seconds. So it's widely implemented. So I can put here the tag, yes, it's widely implemented. It's a good choice to use simple features SQL. So your package is going in the correct direction. Another good thing about simple features SQL is that it's not only an OGC standard, but also an ISO standard. So if you don't know, OGC has some agreements with a lot of standard development organizations such as ISO. And an OGC standard can become an ISO standard. We just need to reformat it, but it's the same spec. In OGC, you will get it for free. In ISO, you will buy it, but it's the same one. So it's widely recognized. Good. Now let's talk a little bit about, this is maybe too small, but the geometries that are supported in your package. So you will see that this is based on the simple features SQL specification. So you have geometry, points, line string, polygons, multi-points, multi-line strings, multi-polygons, and geometry collections. So those are the basic types, the basic geometry supported. So what else? There are various ways to encode these vector data. And there is a thing called well-known binary geometries, right, that encode this in what we call blobs or binary large objects. So this is an example, for example, of how you encode a point in binary. So it's very good because we are using, I think, the best way to encode. So it is very small footprint. And we can support, or GeoPackage can support, linear 2D geometries with optional elevation and measurement values. So you can have, XY, XYZ, and XYZM, for example. This is also a screenshot of the simple features in tables. You will see that we have one geometry per column. And another advantage of using SQLite is that we can also, for example, use R trees that allow spatial indexing, for example, when you want to do range queries. Then the three point that I want to touch base is the support for raster and tiles. So the data model was implemented based on MB tiles specification. And the same file, the GeoPackage file, can store all the information that you need to understand the raster and also the tile parameter if you want to have tiles in different tables and views. So let's recall a little bit about what we mean by tiles. Remember that when we have a map, for example, we discretize the space into various zoom levels, right? And then for every zoom level, we have a set of tiles. So for example, here in this green part, we will show, or dark green, we show the array of tiles for the second level. So we want to be able to capture all that information in your package. So this is how a tile matrix looks like. So you have all the information, for example, that says zoom level, what is the matrix width, the matrix height, what is the tile width in pixels, the tile height, and what are the units of those pixels in the tiles. So that's the description of the tile matrix. Then you have the description of the tile data, which says, well, that is zoom level, this is the tile, column, tile row, and the tile data, which is this blob that I was talking about. Now, for raster, we have different information that we want to capture. So we can capture, for example, the elevation coverage, and we can provide here an image, like photograph of the area. And we also provide the raster metadata, right, in order so you can process it, so you can capture information about was it geo-rectified or octo-rectified, what is the mounting box, what is the minimum, maximum location of that raster. No, so that's about your package. Do you know where the document lives? Anybody? Okay, so some of you may say, well, so it lives inside the portal, you need a membership account. Nope. So we have changed a lot of things in OGC, and it lives in GitHub. So maybe some of you already know about it, but it's really open for everybody to see it, to comment. You can get cool examples. You can see the latest draft. It is really, really, really very good for the whole community. Now, who makes the decision about, at the end, what pull requests or changes go into the final version? This is the working group. But at least we are having the openness for everybody to participate and express their comments. So if you see, there are a lot of folks, OGC members and non-members, that participated in when the draft was being developed. Another thing I want to talk about is at OGC, the implementation standards have something at the end that we call an abstract test suite, which is a set of rules that says, well, if we want to test, for example, your package, we want to see if the header contains these number of characters that have this kind of information and so forth, and we want then to create an executable test, right, which is an implementation. We do that using Java, using TestNG, and when we have an executable test, we can put that test in the OGC testing facility. How many of you are aware of this testing facility, are not aware of this testing facility? Okay, very good. So I said something that was new for you. So this is a free for use, everybody can use a free testing facility where you can test WMS specs, GML 3.21, even profiles of GML, WFS2, KML. And in the future, hopefully we're going to have your package. We use also this testing website to provide certification. So whenever folks pass the test and want to get the license, then we have proof that they passed the test. So where does the executable test suite? A couple months ago, this was in the OGC SVN repository. And a lot of folks were always having problems that Anonymous is not working because we had only one branch of SVN open. Well, now all OGC tests, all of them, are in GitHub as of 2 weeks, 3 weeks ago, all of them. Not only they are in GitHub, but they are Mavenized. In Spanish, we say it Mavenized. In English, Mavenized. In German, Mavenized. And most of the tests that we're doing now are based on TestNG, which is based on JUnit, is Java, is much simpler than what we're doing before. We're using something called compliance testing language that was based on XSLT. So now we use TestNG. And we're open to improvements always. So if you look, so you will see that has the Maven structure, and then you will get to the actual code that implements the abstract CSS that I was going to talk, that I talked about. So if you want to learn more, I will make these available. I will tweet about them in 1 hour or so you will have all the slides available. FOSS, I think, will have them pretty soon. But there is a nice webinar that shows how Carbon Project, Luciad, and Esri are implementing now GeoPackage. So it's very cool. And this is the document link, and this is the spec number. Now, part 2, I think I have like 5 minutes. Yeah, nobody's monitoring me. I have 20 more minutes, okay. So then the next part is, how do we easily share what we're viewing? Right, that's one critical thing. Don't say GeoPackage because I'm going to talk about another spec. But let's say I'm viewing a cool map. I have created some annotations. I have put together some cool layers. How can I share these? Right, I have multiple layers from WMS. I can have a map with GML annotations. I can have a map with SVG annotations. And, And I want to skip the slide. So let's say we have, right, this guy that have created, for example, this nice map that comes from, for example, WMTS and Web Cover Service, randomly in the cloud using web processing service, then was able to annotate manually, hey, this is the path of the hurricane and the critical time is at this time. So this dude, have spent a lot of time doing this map. Right, and wants to share with this guy. I have all this data. I have annotated. I will send you what you send. Now, previously we have an spec that was called map context. How many of you were aware of that? Okay, so what we're using right now is OWS Context, which is very similar. You have a document that captures all those links, references to the services, and where I actually got the data plus GML annotations. I can set that file, for example, via email. The other guy gets the file and then is able to open because you can use the reference to get the data. So that's what OWS Context is about. Now, there are a couple of cool things about OWS Context. One, they're wrapped via atom feed. So, this I think cannot be better for the whole community that are used to parse atom feeds. Is very popular. So we did the experiment. We put this information in an atom feed, and we just tried to open it with Google Maps without telling Google anything. Right away, it opened. So it's a spec that works with current technologies right out of the bat. And this is a WFS offering example. Well, you see here, there's an operation. Then you describe the operation, which is the get capabilities, which is the entry point for the WF service, and then the actual get feature in this case. So in the anatomy of context document is, extends the atom XML format. It contains these entries that are offerings, OGC services, but all these offerings can also be files, and these files can be referenced via URL or can be inline. The OGC service offerings contains two things, the get capabilities and also the request to the data, right? So if it is a sensor observation service, it will say get observation, or if it is WFS, get feature, and offerings don't have to be special. So we did not put any constraint on that. Following also the same idea as how we are treating GeoPackage, OWS Context documents, examples, tutorials, they all live in GitHub. So you are also welcome to go in, participate, comment, fork, pull requests, do whatever you want. And the executable test suites, because we need those to provide the testing in the web testing facility and also for organizations that want to get certified, also lives in GitHub. These are the document links. important to note here, if you see, well, there is an OWS Context conceptual model. Then there is another, this is the same document, is our OWS Context Atom Encoding Standard. So they are, it's a different document, right? And then we have a third one, which is PER, which is Pending Engineering Report. In that engineering report, is going to tell how to use JSON, which is the next thing that we wanted to do with OWS Context. Okay? So final thoughts, I don't want to use a lot more time. So if you are interested, and this is really a call for you to participate or talk to me, I'm very lonely here, so talk to me. I'm not so lonely. So if you want to advance the test, I really, really, really need help. We don't have anybody in OGC doing the test. So the folks that are helping with the test are in-kind contributors. Because, I don't know, the sponsors don't want to pay for the test. Sometimes they did, but it's very hard to get funding for tests. So if you say, I found very useful to have a testing facility to test your package or OWS Context, or the others, for example, we're working a WMTS test that is taking like 30 minutes. And because somebody did it, they gave it to us, but it's taking very long. And we have people working on it, but it goes very slow. So if you want to participate and see the other tests that we have at OGC, please welcome. How many of you know about Inspire? Inspire are reusing the testing facility, so it's generating a lot of momentum of the tools that OGC has. So I welcome you to participate in that, advancing the test. Second, we have reference implementations at OGC, and I know people have sometimes a definition of reference implementation that is the one reference implementation. So if anything fails, I just look into that and I just copy and follow this one. No, at OGC we have several. And that's good, because we have a spec and we have several reference implementations that all pass the test. So you can take a look at the three of them. If they all pass the test, for me, they are reference implementation. And we have made also a less constrained reference implementation. They don't need to be open source. They just need to be publicly available for exercising. But all of them, the ones that we have, are open source. So anyway. And if you want to contribute to the specs, you know how to do it. Go to the document, go to GitHub. It's very easy to create a comment and then submit the change. The working group will take a look at it and then will act upon. And then if you have any other ideas, new technologies that you say is cool to bring to OGC or whatever, just let me know. Luis Bermudez, this is my email. I don't use too much Twitter, but anyway, if I get something, somebody will tell me, hey, respond. So that's all. Thank you very much.
Any questions?
In the GeoPackage, can you attach metadata, like ISO metadata, inside the GeoPackage with the data itself?
I don't know if you can attach like an ISO metadata record.
Yeah.
I'm not sure about that. Well, you should. I should be no, or I should be sure?
You should know. No, it should be possible.
Yeah, I think so, because you can, but I don't know really. Yeah, I think so. But
It's an interesting requirement because just pick this up and there's a metadata table in the GeoPackage standard. I know that Esri doesn't fill it with anything at the moment. Perhaps in the future they will. But I guess I got the mic. On the same topic, though, what about the spatial tables? Because there is a tendency for most of us to think of this like an Esri file geo database where you throw everything into it. And for the most part, I'd want to throw everything into my single GeoPackage file to give to my collaborator that I'm sending it to. Is the plan just to have that sort of open, that we can you have this structured bucket that has the metadata necessary for the feature classes. And if we want to throw in a few other items, you know, shrug, or would that become more part of a standard to tie into the question of the metadata? Because I would like to also add metadata about my non-spatial tables as well.
So I think there is a minimum set of tables that contains the information about what the file contains. So you don't need to have everything. If you just want tiles, for example, you can put tiles. If you just want vector data, you can do it. So you don't have to have everything. You just pick and choose. Now you can define your own feature data. So maybe you say, well, maybe I can encode a metadata record in the tables as it's, you know, feature and attributes. The question is if there is a way that the GeoPackage standard can understand that I'm attaching an ISO metadata record or a metadata record. So I don't know. Of course, there are ways to do it, but you know, I will ask and then contact you with the correct response.
All right, thank you.
Thank you.